So first I will discuss what is the circuit turn-up time. Okay. So normally we are using this kind of devices, thyristors. So this device will be in reverse in a cycle we will observe. Let's say two pi cycle is there. Okay. So out of 2 pi cycle, for how much duration our device is in reverse base? Okay. For how much duration this device is in reverse base? These two are the criteria to measure the circuit turn-up time. So let's say for 60-degree, it is in reverse bias, and for this 60-degree duration, current through the device is also zero. Okay. So this will be the circuit turn-up time. So we can say that omega Tc is equal to 60-degree, and from here we can calculate the circuit turn-up time. So two terms are there: device turn-up time and circuit turn-up time. Okay. So device turn-up time means this is a device. It requires some time to completely turn off. Okay. So device turn-up time should be always greater than or equal to circuit turn-up time. Okay. Let's say TQ. TQ we are called a device turn-up time, and TC. So sometime we'll take 1.5 of 1 second. I think I'm telling incorrect. One second. See, device at some turn of time, that time is required. So TC, circuit turn of side, should be greater than or equal to some safety factor into TQ. Here TQ is the device turn of time. So this much minimum turn of time is required to completely turn off the device. And this circuit turn of time, if it will be greater than this one, then only that device will be completely turned off. Is it clear? Otherwise, I will explain again.
So
Clear?
safely commutated, sir, that one
Yes.
point.
So if this device turn up time into some safety factor, so circuit turn up time should be greater than or equal to, then only it will be completely turn up. Okay, so that's why we are selecting some safety factor here. I think it will be clear. So these two
But
criteria we
normally it is in range of 1 to 2, sir, or 2 to 3, sir.
Sir, once again explain, sir.
okay, see, any thyristor circuit is there in normal rectifier. We are normally using thyristor. So these two lines we have to remember. This is the concept for the circuit turn of time. So how we can calculate the circuit turn of time? So device should be in reverse bias. That too here, when a star point is there, it should be in continuous reverse bias. Let's say this is a 360-degree cycle, and our device is reverse bias here for some duration and some bigger duration here. Okay. So this only we will consider for the circuit turn of time. Here, like it is at this point, someone can do mistake. Like they will add this one and this one. No need to add this one. The concept is it should be continuous in reverse bias in a particular period. So let's say this is 2 pi period, and here continuous reverse bias period. Let's say this is 60-degree and here 5-degree. So omega TC should be equal to 5-degree.
60.
60, yeah, 60, correct. It should be equal to 60. It should not be equal to 65. Okay. So the concept is it should be continuous in a reverse bias period in a period for a duration, and the current through the device should be zero. So this duration we will call it circuit turn-up time. Okay. So one term is there, device turn-up time. So device turn-up time means that minimum time is required to completely turn up that device. Okay. So if it will be in reverse bias, so one relation is there. PC should be equal to greater than equal to safety factor into TQ. So let's say TQ is some 1 microsecond. Okay. So TC should be greater than, circuit turn up side should be greater than 1 microsecond, such that the device will be completely turned off. Is it clear now?
Okay, sir. Clear. Clear,
Okay.
sir.
So same thing I will explain for the three-phase rectifier circuit. So first one case is alpha less than equal to 60-degree. Okay. So one case I am considering here, alpha is equal to 30-degree. 1 second. One case I will consider here, alpha is equal to 30-degree. So first I am going to draw the waveform. This is the reference point. Okay. So where 30-degree will come? it will come here and waveform will start from here. So this is the waveform. Output voltage first I am drawing, and it will be clear. It will come here, I think. Oh, 360 and 360 2 pi here. Is it clear? This waveform, output voltage. Already last class I have taught. This is only output voltage. I am going to draw the VT1 voltage thyristor. So for device turn of time, we will draw the voltage across the thyristor. So any thyristor if you draw, you will get the same thing. So I'm going to draw for the this thyristor T1. Okay. So after drawing this waveform, we can simply write the notation. So AB means 6 1. Here it will be 1 2, 2 3, 3 4. Here it will be 4 5. Here also it will be 4 5, and here it will be 5 6. Okay. So when one will conduct, switch one will conduct, what will be the voltage across that switch? When that switch will conduct? Here to here.
VAB.
No, that switch one will conduct. In that case, it will the voltage across the switch will be 0. Okay, because that switch only is conducting. So when switch one is conducting, so voltage across this will be short circuit. So VT1 here plus and here minus. This is VT1. Okay. So when this switch will be conducting, what will be the voltage? That will be 0. Is it clear? So here to here it will be 0. Here to here the volt, because since switch 1 is conducting, here 6 1 and here 1 2, so the voltage will be 0. And when 3 is conducting, okay, so where is the 3? 3 is here. Okay, if 3 will conduct, what will happen? This B will connected to this point and A is already connected here. Okay, so if 3 will conduct, conducting switch, if 1 will conduct, VT1 is equal to 0. 3 will conduct, what will happen? VT1 is equal to VAB. Okay, and if 4 will conduct, so no, here 4 is here, 5 will conduct, what will happen? 5 will conduct means C will be connected to the top point. So the VT1 will be VSC. Okay, is it clear? Otherwise I will explain again. Can anyone reply?
We have used KVL, sir.
See, just simple. A is already connected here, this point. Okay, I want to calculate VT1. Okay, when this T1 will be on, then this point will be short. So what will be the VT1 value? That will be
0,
0.
sir.
Okay,
0, sir.
if T3 will conduct 3, I'm only considering upper switches. So 1 is conducting means this is 0. If 3 will conduct, what will happen? This B point will be connected to here. Let's say this is X point. Okay. So if 3 will conduct, this B will be connected to X point. So what will be the VT1? VT1 will be VA minus VX. Okay. So if 3 will conduct, VX will be VB. Okay. So what will be VT1 in that case? That will be VA minus VB. That will be VAB. Okay. Similarly, if 5 will conduct, what will happen? This C point will be connected to X. Okay. So if Vx will be Vc, what will be A minus Vx? That will be VAC. Is it clear now?
Exactly, yes, sir.
Okay. So by
VAC. 5 will conduct VAC.
yes. So this is the table. According to this, we can draw the VT1. So this here I am drawing the VT1. So if you'll see here to here 6 1 and 1 2, so it will be 0. Okay. Here if you'll see 2 3 3 4 4 5. Okay. So here 3 is conducting up to here. And if you'll see here 3 is conducting. So 3 is conducting means what is the voltage? AB. Where is VAB? This is the waveform VAB. Okay, so it will follow the VAB. here to here. Here to here it will follow VAB. Okay, 4 5 again. So here 4 5. So 5 will conduct. What will happen? VAC. Which one is VAC? This one. This is VAC. Is it same? See this one. This first, second, third is VAC. First, second, third. Third will coming here, 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 here. So after this point, it will start following VAC. Okay. And here also it will be if 5 will conduct, what will happen? This side. Here 4, 5 and 5, 6 is conducting. So which is VAC? AC, this one. This only. So it will be like this only. Na? Is it clear? Hello? Can anyone reply? Am I audible? Hello? Hello?
Sir, that
Sir,
waveform
Yes,
was
sir.
explained, sir.
Okay.
The VAB we got, sir, that one.
Okay,
We,
see. So 4, 5 is there. 4, 5 is conducting here after this point. Okay. So here to here it is 2 pi. Here pi and up to this point it is 2 pi. So after here 4, 5 is conducting. So 4, 5, 5 will conduct means it will come as VSC. Okay. And which is VSC waveform? I will write here also. CB, AB, here it is AC. Okay. So AC is this waveform. This waveform is AC. So after this point, since 5 is conducting, so it will shift to AC waveform here to here. Before it was following AB here to here, it was following AB, and after this point it will shift to AC. Okay, and here to here it was 0. Again, if you'll see here, 4, 5 and 5, 6 is conducting. So anytime if 5 will conduct, what will be the voltage? That will be VSC. So that will from here to here. Is it clear?
yes, sir, clear, sir.
Okay. Now we'll see the reverse bias angle. How much is the duration here to here? This will consider. So how much is this one? This is 60, 60. Okay. How much? 60 plus 60 plus 30, I think.
Plus 30.
How much total? 120,
Mm,
150.
150.
Okay. So, 1 second. I have done any mistake. Should be. Huh. So what we can write here? This one less than equal to 0. Second one I will draw for 90 degree. So this is how we can relate how much minus alpha, like 180 minus 30 we can write this one.
Yes, sir. 180 minus 30 equal to 150.
That one, yeah. Okay, 1 second. Are you doing any mistake? AC, AB, BC, CA. Is it this notations are correct? Can you verify once? This first one is AB, then BC, then CA. CA is this one, and AC is this one. Okay. Oh, C.
Starting that one CA, sir.
CA. Hmm?
CB.
Hmm?
That last one, green pen, CB, I think, sir.
This one? Last one?
Sir, we are starting CB.
Okay.
At last also
No, no, the
something
last one
like
is CA. See, first one is AB. Okay. Then after 120 degree, this is BC. Okay. Again after 120 degree, CA. Is it clear?
Mm,
See, but one thing we can, this will come here only, na? I think if we'll see, 1 second at a time. If we'll see here, this one also will come here, I think. If we'll see this point here, it is continuous only here, I think. Hmm? See, this point now. So I think this should considered because continuously 0 to 2 pi only we should not consider. Here see, continuous turn off is coming, no gap is there. Okay. Now what is the angle? This one. This only mistake we have done. What is the angle now? This one. Since this is a continuous turn off, continuously we are
mm,
getting. What is this angle? Here to here. 60, 60, 60, 180 plus 30. How much?
D.
Hmm?
210. 210.
210. Okay. So the formula will be for this one, we should what we should memorize 240 minus alpha. 240 minus alpha. Omega TC should be equal to 240 minus alpha when alpha will be less than equal to 60 degree. This direct formula we should memorize. Okay. 240 minus 30 if we'll do, what will happen? 210. Okay. So this we have to remember. For three-phase full bridge rectifier, if alpha will be less than equal to 60 degree, omega TC should be equal to 240 minus alpha. Is it clear?
Yes,
If
sir.
n,
Clear, sir. No.
Sir,
okay,
omega T1, sir, conducting 240, sir, verify, sir, from diagram, sir.
this one 240, okay, see, continuous turn off, we'll see, here to here. So this 60 degree, this 60 degree, this 60 degree, okay,
Yes, sir.
and this 30 degree.
30 degree.
So 60 half 30, so 60, 60, 60, 180 plus 30. This is 210. Okay. So if we'll write what is the 210 angle, 210 we can write as 240 minus alpha. 240 minus 30 I can write 240 minus 30 is equal to 210. Okay. So I can write that here we are getting circuit turn of time as 210. Okay. So generalized equation I can write as 240 minus alpha. This should be equal to omega TC. So here alpha is 30 degree. So if we'll do that, we'll get the 210, this value. Is it clear? Here to here. Just I'm
Okay, sir.
writing a generalized formula for any angle. If we'll draw this waveform, we will get this value only. If alpha will be less than equal to 60 degree, and if we'll draw the same waveform, we will get this one 240 minus alpha. So that reverse bias period will be 240 minus alpha. I think it is clear.
Okay, sir, clear, sir.
Okay.
But please, in case circuit turn of time, can we express in seconds, sir?
Okay. So
Is it possible?
what you are asking? Any other angle?
Circuit turn, circuit turn of time can be expressed in terms of seconds, sir. Is it
Yes,
possible?
yes. So omega is 2 pi f, 50
Yes, sir.
degree. So T will be 240 minus alpha by omega. Okay. For 50 hertz frequency, this omega is the frequency of the source voltage. So 50 hertz frequency, it will be 2 pi f. So
Okay,
T
got it,
will
sir.
be 240 minus alpha by 2 pi into 50. Okay.
Okay, thank you,
Generally,
sir.
if it will
Got
be
it.
asked in numerical, we have to calculate by this one. Okay.
Okay. Thank you, sir.
Okay.
Got it, sir.
Okay. So coming to the next case. So this one alpha greater than 60. So I'm choosing a value alpha is equal to 90 degree. Okay. So let's draw the waveform first. So this is a 0 where it come 90 degree, this 60 and this 30 90. So it will start from here. It will start from here and it will follow this path. Okay. So 360 and 360 here. 2 pi and 3. Okay. See. So this will be the output voltage for 90 degree. Okay. From here we are measuring 90 degree will for AB phase 90 degree will come here. So I'm starting at this point. It's 60 plus 30 90. Okay. So one thing like how we can start, we should be a starting point. This we should memorize. This numbering 1, 2, 3, 4, 5, 6.
Sir,
Yes, you can ask.
sir, in last diagram, you draw a peak value of output, and here, sir.
Which
Yes,
one?
sir.
Here, previous one.
Sir, in previous one, we draw peak
Okay.
value, sir. And in this diagram, sir,
What is the peak
uh,
value you are asking?
sir, just like VAB, VSC,
Yes, yes. This all are line
and
voltage. This all are
sir,
line voltage. Okay, not a phase
yellow.
volt.
It's saying that output voltage decreases now, sir, that amplitude
Yes.
in alpha greater than 90 degrees.
Yes. So here, this is the output voltage. Yellow color waveform is there, or alpha is equal to 90 degree. Uh, I'm not getting. What are you asking? This waveform I have to explain.
Yes, sir. I'm asking
See,
about.
this is for alpha is equal to 30 degree. Okay. So alpha, how we are measuring? This is the reference point. This is my reference point for VAB. This is AB, first waveform is AB volt. Okay. So after this point, 30 degree will come here. So here AB waveform will start from here. So this is the reference. After 30 degree will come here. So here I am starting the AB. Okay. Similarly, here if you'll see, this is the reference and 90 degree. 90 degree means here to here 60, 60 plus 30, 90. So AB waveform will start from here. So it will go up to here. Similarly for AC, this is the reference and AC waveform will start from this 60 and this 30, 90. So it will start from here. This AB and this AC. Okay. Similarly, it will follow. Is it clear? The previous class you have not attended, I think. Hello.
Yes, sir.
See 6 1. So I will write here 6 1. AB means 6 1. 6 1 1 2 2 3 3 4. And it will be 5 6 4 5 3 4. Okay. Like this sequence should be like this. Okay. So main thing we have, first thing we have to remember this circuit. We have to remember first the sequence 1 2 3 4 5 6. Step 1. After that, this should be the reference point. After this, we will measure the angle. So here angle is from this point 90 degree. So 90 degree means it is this one section is 60 degree here to here. So 90 means 60 plus 30. Okay. So here to here 60, 60 plus 30 this middle point. So AB will start from here. It means 6 and 1, this 1 and 6 we are triggering at alpha is equal to 90 means here to here. So if we'll trigger 6 and 1, what will be the output voltage? Output voltage will come as VAB. That's why from here, to here, it is following the VAB waveform. Okay, here
Okay,
to
sir.
here.
Okay.
Similarly, for AC, AC reference is this one. So what is the 90 degree for AC? This 60 and this 30, 90. So AC will start from here. Okay. So just we have to draw one waveform, another will be repeated. Like here, see, previous case, first waveform I have drawn AB, again same AC and all will be the similar kind of waveform. Okay, it's easy only. Once you will try, you will get it. So now output voltage I have drawn. We can draw the T1 voltage, VT1. Okay, so same thing we can do. If T1 will conduct, what will the VT1 value? It will 0. T3 will conduct, what will the VT1 value? That will be VAB. And T5 will conduct, it will be VAC. Okay, we'll see here. So it is conducting, one second, this point is matching. This point, I think it will come here. 1, 2, 3. Okay. So here to here it will be 0. And again it will come. So what will the voltage if 3 will conduct? VAC. Which one is VAC? AB. This one is AB. This one is AC. AC is this one. So it will be here to here. Okay. And if 5, 6 will conduct, what will happen? No, 6. So 5 will conduct, what will happen? 5 will conduct, it will be, no, here 3, 4, 3 was conducting. Na? So in case of 3, what is the voltage? VAB. I have done mistake here. Is it clear? This first waveform, it will be, if 1 is conducting, it will be 0. If 3 is conducting, it will be VAB. Which one is VAB? This first one. Going from here to here to here. So, we'll start here. VAB. Okay. And if 5 will conduct, what will happen? VSC. Which one is VSC? This one. Okay. So, this one is VSC. It will come up to here. Which point? Here it will come. Is it clear? Can anyone ask? Reply. Like you can also see which what I am trying.
One AC waveform, sir. P5.
So
Yes, sir. Got it, sir.
this side it is clear. This is VAB.
Next is AB, sir. Next waveform AB.
Here it is AB, and
Um,
up to here it will come as AB. So I think
Before only, sir. That one.
this one like this it will be.
Yes, sir.
See. So here if you'll see, we will not get here continuous because here after some positive will come. Okay. After that it will go negative. So that will not come a continuous reverse bias. So what will be the continuous reverse bias? What is the continuous reverse bias time here? This only will come 90 degree, 60 plus 30, 90 degree. See, here after this if you'll see, first it will go top, then it will go come bottom, then again it will go. But previous case what was happening? It was following reverse bias continuous. So that's why we have considered. But here if we are seeing, see this waveform here. When 5 is conducting, it is VSC. Okay. When 4 will conduct, again it will shift to VAB. So here to here it is VAB. Again it is coming and it is tracking VSC. Okay. Here it is 0. Again here it is VAB. Here it will come VAB and again it is VSC. So if you see here, this 90 degree is continuous reverse bias period. Okay. So that we can write as 180 degree minus alpha. Here we can write as 180 degree minus alpha is equal to omega TC. Is it clear? Continuous reverse bias. Like if we'll do mistake, we'll consider this one also. That will be wrong. Okay. So for alpha greater than equal to 60 degree, okay, the standard equation will be 180 degree minus alpha. This should be equal to omega TC. Is it clear?
Yes, sir.
Okay. So these two standard equation you should remember. For alpha less greater than 60 degree, 180 omega TC is equal to 180 minus alpha, and less than 60 equal to 60 degree, this is 240 minus alpha. Okay. So these two you can write. So now I am moving to one question that is asked in GATE 2006. Okay. So everyone have clear previous concepts? Can I discuss
Yes,
this
sir.
question now? Okay.
Clear, sir. Clear, sir.
Okay. So this question is asked in 2006. A solar cell of 350 volt is feeding power to an AC supply of 440 volt, 50 hertz, three-phase, fully controlled bridge converter. A large inductance. So inductance is given such that the current has a ripple-free 20 ampere, and if resistance is 0.5 ohm, then each thyristor will be reverse biased for a period of. So we have to consider, we have to calculate the continuous reverse bias period of a thyristor. Okay. So how first what we can do? First we can calculate the value of the alpha firing angle. Okay. So like for reverse power feedback, we have to change the polarity of the EMF. Okay. For regenerative braking, what is the concept? we are changing the polarity of the battery and we are making the output such that output will be negative. So negative means here it will be plus and here it will be minus, such that it will fade power in this direction.
E
Okay.
greater than V, sir. E greater than V.
E should be greater than V. So this output voltage, and why we are changing this polarity? Can anyone tell? What is the reason? We can make this side polarity also higher and this side polarity also lower. Then also can it transfer power in this way? Let's say this is output voltage. Okay, I'm making it positive, and this is the EMF. In between some resistance is there. Can it feed power back to the source in this way? If not, why? Is it possible?
Possible, sir. Regenerative braking.
No. Just I'm
No,
asking
sir. No, sir.
why? Why it is not?
The
Inductance doesn't
thyristor will
change
be in
current flow, no, sir.
reverse bias. The thyristor
Yes.
cannot allow.
Thyristor cannot allow current in a reverse direction. Okay.
Yes,
That's
sir. Yes, sir.
why
Got it.
for inverter mode of operation, alpha should be greater than 90 degree. Then it will output voltage will be negative, here plus and here minus. Okay. Then it will flow the power in the reverse direction. Okay. So from this condition, we can calculate the value of alpha first. So let's say this is plus minus V naught. Okay. So V naught we can calculate. So what will be the V naught value? V naught, what is the current? 20 ampere. So V naught minus V naught plus 20 into 0.5. Okay. Minus 350 is equal to 0. So what will be the V naught value? V naught is equal to minus, how much? It will be 10. Minus 340. Is it correct? So, is it correct? Can anyone see this equation?
Yes, sir. Minus
So
340.
3 VML upon pi into cos alpha, this should be equal to minus 340. Okay. What is the VML? 440 is the RMS value. So 3 into 440 into root 2 divided by pi into cos alpha equal to minus 340. From here we can calculate the value of alpha. Alpha will be cos inverse minus 340 into pi minus 34. All of you can calculate this one into pi divided by 3 into 440 into root 2. 125 I am getting approx. What we are getting? So alpha is 125 degree. Clear?
Sir, 124.9, 125, sir.
Yes. So already we have done that equation. What is?
We can eliminate these options like this, no, sir. Alpha is greater than 90, inverting operation, 60, 50 is eliminated, no, sir.
See, omega TC already we have to, this is alpha greater than 90 at 60. So what is the condition? Omega TC is equal to 180 minus
180 minus alpha.
alpha. So that will be 180 minus 125.
125.
How much it will come as? 55 degree.
55 degrees.
So
Sir.
this will be the correct option. We can see it from waveform also. Okay, so here I have drawn the waveform. So for 125 degree. Okay, 1 second. I think should I start? Should I omit? And I think it is not looking correct. I will start. I will omit and start. Okay. So we'll draw fresh. So this is VAB. 1 second. I think here also I have done mistake.
That one changed.
This is also not correct. I think it is
Sir.
shifted. This waveform is shifted, I think, left and right. That we can do. 1 second. See. Now is it okay?
Okay, sir. Now, okay, sir.
Okay. So we can draw first the output voltage. Okay. So this is the reference. Okay. Here to here 60 degree, 120, and this is 60. So let's say 125 here it will come. Okay. I will start the waveform from here. AB will flow from here. So for this one, if 125 is coming here, for AC where it will come 125, this 60, 60 and one here it will come. Okay. So it will follow this waveform AB. Again, it will follow AC waveform from that point, this point. Okay. Let's say this point. So it will follow AC. Again, it will follow this. Is it clear now, this waveform? So every point it will start after 5 degree. Each one 6, 1, 1, 2. Okay. Here also it will come here up to here. Again it will come here and okay. Is it clear, this waveform? So 2 pi where it will come? 180 and 180. 2 pi will come here. It will go extra in next cycle. It will start again from here. But 2 pi is stopping here only. Can we draw the waveform now? So see 6112, this is 2, 3. This AB here 6112, 2, 3, 5, 6, 4, 5, 3, 4, 2, 3. After 2, 3 it will come as 3, 4. Is it clear? Here a small portion will come 2, 3 for 5 degree. Is it clear to all? Otherwise I will explain again. Can anyone reply? Hello.
Clear, sir. That one.
Okay, see. Now, so now we can draw the device voltage. So 6, 1, 1, 1, 2, what will happen? 6, 1 and 1, 2, here to here. It will be 0. Okay. 6, 1 and 1, 2, it will be 0. If 2, 3, what will be the voltage? So 3 is conducting. That will be VAB. So where, which one is VAB? This one, you know. This one. Okay. This is going here to here, here to here. Here it is going up to 2 pi. So it will come here. After 5 degree, it will end here. Is it correct? Is it clear? This is VT1 voltage. So where this 2, 3 is conducting, that time what will be the voltage? Voltage will be VAB. See here 5, 6 is conducting, 5 is conducting. What will be the voltage? Here to here, 5 is conducting. What will be the voltage? VAC. So which one is VAC? This one. It will go here. It will follow VAC up to here, this point. Okay. Again, after this, here 5 degree is there. So 3, 4 is 3 is conducting. So 3 is conducting means it will be VAB. This will be VAB. Before this 5 degree is there here. And what will happen if 2, 3 is conducting? They are also VAB only. Is it clear? Here 2, 3. A small portion. So that will be VAB only. Is it clear to all? Should I explain again? Can you reply?
Only small part is reverse bias, sir. That one
No,
only
see,
55 degree.
this one only. So
Yes,
60
sir.
minus 5. 60 minus 5, this is what?
55 degrees.
55 degree. Remaining waveform is clear, this side?
Yes,
Here.
sir. Clear, sir.
Okay. So just for like explanation, I have shown this waveform. No need to do this kind of thing. Already, if you'll remember this standard formula, omega t is equal to 180 minus alpha, directly we can apply this formula. Okay. So this will be
Okay, sir.
okay. So now I'm moving to the next question. Okay. This question is yes, you can ask. Yes.
Sir, how can we know that it is for it is for alpha equal to alpha greater than equal to 60 degree or less than equal to 60 degree.
See, here I have calculated the alpha value first. So alpha what I am getting the alpha value 125. By solving the question, I have calculated the value of the alpha here. Just by writing the KVL equation here, this current was given. Okay, this voltage EMF was given. So simply we have applied the KVL in this one. So this V naught is equal to how much we are getting? Minus 340. So to feed back the power, this V naught should be minus 340. This power, this 20 ampere current, this output voltage should be minus 340. So I have applied equation. So 3 Vm pi cos alpha, this should be equal to minus 340. And by solving, we got that 125. So 125 is greater than 60 degree. Okay. So if it is greater than 60 degree, we'll apply this one. Is it clear?
Yes, sir.
Okay. Okay. So now moving to the next question. This is very good question. Like 2011 gave. So here, same thing is happening. The battery is feeding power back to the source. So how battery can feed power back to the source? That polarity should be like this one. Okay. They are saying that 400 volt battery is given. Okay. And some resistance is given here. So they are asking what will the maximum value of the current through battery.
Sir,
What
40 amp.
yes. So see, when here, if this voltage will be 0, this can be any value, like let's say 10, 15, okay. But when it will be maximum, when this value will be 0. So if it will be 0, I will be 400 by 10, that will be 40 ampere. Is it clear? I think all of you know this question. This is familiar. I think maybe you have solved previously. So this is 40 ampere. I think, is it clear to all?
Please, sir.
Okay. So what is the kVA rating of the input transformer? So input side one transformer is given. Okay. So
22.6 kVA, sir.
this is the answer. Okay, correct only. So what will be the value for any kVA rating? Root 3 into VL into IL. This is the kVA rating. Okay. And we already know the output current. So output current is known. What will be the source current? That for three phase, IS is equal to under root 2 by 3 into I naught. This already we have derived. Okay. So this one we can apply. Root 3 into VL how much? 400
400.
into root 2 by 3.
32.65.
Okay. And here it will be I naught 10. So this will be kVA of the transformer.
Sir, 40, sir. Root 2 by 3 into 40.
Okay. Output current how much? 40 ampere as 40 ampere. So this we will get, I think this one is the correct option. Is it correct? 22.6
Yes.
kV.
Yes, sir. Yes, sir.
Okay. Should I move to the next question?
Yes, sir.
Okay. Okay. So, so see, if purely resistive load will be given, which value we should consider? RMS or average? Already this concept I told in previous class.
RMS, sir.
RMS, sir.
Yes, because both the voltage and current will be variable. If two functions are there, the instantaneous power, how we can calculate? P instantaneous is equal to V into I. Okay, and what is P average? P average is equal to 1 by T VI dt. So if resistive load will be there across the resistance, voltage and current both will be variable. Okay. But if any of this function is constant, let's say either V is constant, let's say battery we are supplying. Okay. Battery we are supplying something, or constant current we are supplying to some inductive load. So current is constant. So any one part will be constant, that will be taken outside. So what will be the other term? Average of the voltage. Okay. But in case of resistive load, since both the values are variable, so we will use the RMS value. So here alpha value is given as 90 degree and it is a purely resistive load. Okay. So this waveform already I have explained. Now also I will explain this one. So if purely resistive will be there, what will happen? It will not conduct in negative. Okay. So this is the reference. This is AB. So what will the alpha is equal to 90 degree? Where it will come? Here 60 and 30 90. Here it will come. Okay. So it will conduct here. Again, it should go back, but since resistive load is there, It will not go back because current will be 0 and again it will come here. This will be the waveform. Okay. This kind of waveform will be there. Is it clear? For purely resistive load. Clear to all? This will be the waveform. This will be 360. Is it clear to all? This is the output voltage waveform. Alpha is equal to 90 R load. If RL load and highly inductive load will be there, that is this waveform. Already I have, for alpha is equal to 90 degree, I have drawn here. This is for highly inductive. So since highly current is there, it will force that thyristor to conduct and output voltage will be this one. Because here also that T1, T6 is conducting, so output voltage will be negative. See here, here current will become 0. So if current will become 0, that thyristor will become turned off and output current will become 0, so output voltage will become 0. Is it clear? Otherwise I'll explain again. Clear to all?
Clear, sir.
Okay. So now we can calculate the RMS value. What is this for? So for every calculation we will consider VAB. Okay, this is VAB. What is this value? This angle. This angle is pi. And what is this angle? Pi by 6 plus alpha or pi by 3 plus alpha? See, it's 60 degrees. So pi by 3 plus alpha. Okay. So we can calculate the RMS value. What is VORMS? VORMS will be under root 1 divided by 2 pi by 6 pi by 3 plus alpha to pi Vm square. So this Vm line to line square sin omega t d omega t. Is it clear? This equation RMS value. So it will be under root 3 by pi, okay, into VML, and inside it will be sin square omega t. What it will be? 1 minus cos 2 omega t by 2. Cos 2 omega t by 2 pi by 3 plus alpha to pi. Is it correct? So 2 pi by 6 I have taken outside, so that will be under root 3 by pi, and VML whole square, it will be VML, and inside it will be integral of, so here I should take integral. I have done here mistake. This should be omitted. Here we should take integral. So integral will be pi by 3 plus alpha to pi. Okay. Is it clear? Can anyone reply? So it will be, can write 3 by, here it will be 2 also we can take outside, 3 by 2 pi VML into, what will be the first term? First term will be theta only. So 1 by 2 in 2 already I have taken outside. So what will be this value? Pi minus pi by 3 minus alpha. Is it correct? And here it will be, what will be the integral of cos 2 alpha?
Sin 2 alpha by 2.
1 by 2 sin 2 alpha. Okay. So minus 1 by 2 sin 2 alpha pi by 3 plus alpha to pi. So here we know the value of alpha. We can put here directly. Okay. Can you calculate what will be the RMS value? So this kind of question can be asked in 2 marks. Calculation is a little bit lengthy, but we can do. For 2 marks question, let's say it can take 5 minutes. Maybe it will, this question will take 5 minutes. But this type of question, it can be asked in 2 marks. It's not very lengthy solution. Okay. What will be this value? So pi minus pi by 2. Pi by 2 minus pi by 3. How much? I'm also calculating. You can calculate. So sin 2 pi is 0. Okay. Pi minus pi by 2. So pi by 2 minus pi by 3. pi by 2 minus pi by 3. Here it will be minus already it is there. Sine cos. So plus 1 by 2 sine 2 into plus 1 by 2 sine 2 into. So this is how much? 60 plus 90. Sine 180, how much? We have done any mistake? Pi by 3, 60. 60 plus 90, how much? 150.
150, sir, that one.
Okay, 60 plus 90, 150 into 2, 300. That will come here. 60 plus 90, 150. 150 into 2, 300. This one will come now. So sine 300, how much? Minus root 3 by 2 into 1 by 2. How much? Minus root 3 by 4 plus pi by 2 minus pi by 3. Pi by 2 minus pi by 3. 0.09 I am getting. I think is it correct or maybe 0.0905 under root 0.0905 0.3. Final answer which I have written is 67.64. VORMS 67.64. This will be the value. We'll verify this one. So 0.3 I am getting this factor. 0.3 into under root 3 by 2 pi into under root 3 by 2 into pi into VML is how much? 230 root 2. 230 into root 2. I got. So see this factor I am getting 0.3. Here to here, this one I am getting 0.3. Okay. 0.3 multiplied by this one. So 67.61 I am getting. 67.61. Is it correct? Everyone got this value? See how I have done this one. This second part will be minus 1 by 2 sine 2 alpha. So pi, for pi value it will be 0. Okay, sine 2 pi, 180 it will be 0. So it will be plus 1 by 2 sine 300. And first one is pi minus this alpha pi by 2. So pi by 2 minus pi by 3. This is pi by 2 minus pi by 3. This total term will be 0.3. Okay. And under root 3 by 2 pi into VML. What will be the VML? VML value will be 230 into. So see 230 here 230 region means 230 line to line. Okay. So 230 into root 2. This will be line to line maximum value. So that we'll put here VML. Is it clear? Can anyone reply?
Yes, sir.
Okay. So you got the RMS value of the voltage. So what will be the power? Power will be VO RMS whole square by R. So it will be 67.6 whole square divided by 25. How much? Whole square divided by 25.
Sir, is it 3 phase, sir?
183 what we are getting almost. Okay. So this type of question you can practice. For
Sir, yes,
different.
sir. 182.79 watts, sir.
Yes, 182.7. I am also getting the same 182.7.
Sir, this is per phase power.
No, see, yes, it is not per phase power, it is total three phase power. So this what we are getting, this is the load, okay, and this rectifier is delivering this resistive load. So here voltage, we are some voltage we are getting. So how much load is power is taking, that will be delivered by all three phase of the rectifier. These three phases are there, but output side we are calculating the power. So this RMS value divided by R. So what is the output power delivered? That is the total three phase delivered input power. Is it clear? So if per phase they will ask, it is a balance, they will ask per phase, so that will be 182.7 divided by 3.
Sir, here R means equivalent resistance, sir, 25 ohms.
No, no, output resistance. See, the power
Sir,
is delivered to load.
sir,
Okay.
I had one doubt, sir. Three-phase load means it may be star or
No,
delta
no, no.
connected
See,
load.
see, see, see. Again, I will. What is the rectifier? Rectifier means it will convert AC to DC. Okay.
Okay, okay, got it, sir. AC
Okay.
to DC. Okay, got it, sir.
Okay.
Only plus minus.
Yes. Only see output side only DC part will come.
Okay,
So
got
that.
it, sir. Got it.
Okay.
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 Thank you, sir.
Okay. See. So should I do this next question?
Yes, sir.
Okay. Okay. So this question, some random waveform is given. Okay. This some circuit is given. So some circuit is given. Some voltage waveform is given, and they are asking that what is the value of x1, x2 and x3. Okay, so if this type of question will be asked, simply we number the switch as per our notation. So 1, 2, this one 3, 4 and 5 and 6. Okay, one thing they have written here, this vyv is equal to vm sin omega t, yb. So vyb is vm sin omega t. Normally what we are selecting, vab is equal to vm sin omega t. Okay, but here they are considering VAB, YB is equal to Vm sin omega t. So we can write the first phasor I have written here. So one second. One second. So the reference normally we are taking to the phase value. Anywhere, if nothing will be given as reference, so phase will be considered as reference value. So this is phase value. What is the phase sequence? A, B, C, and phasor will rotate in this direction, omega is. What will the VAB? So here they have given RY. So RY B only will R, Y, and B. Okay. So what will the RY? RY will come here. This will be RY. What is YB? VY minus VB. So this is VYB. And VBR, VB minus VR. So that will come here. Okay. So what they are telling, which is the reference we are selecting? VYB. This VYB is selected as reference. So what will be the like next 120-degree delayed value? So what will be
VBR, sir.
this is lagging by 120 degrees, so VBR. That only, na? And minus 240, it will come this one. So see, here we can write the same thing. First we will start from here. So this will be VYB. First will be YB. Okay. So what will come after 120 degree? This one what it will be? This waveform. It will be VBR minus 120 degree. Is it clear?
Yes, sir. VBR.
VBR, and what will be after this value? VRY. This will be VRY. Is it clear?
Yes, sir.
So other thing we can write. So since this, what is this value? This is YB, so BY will come here. BY. Is it correct? That's reverse. I'm taking. This one is 1 second. What will be this value? 1 second. 120 degree will come here. Again 240 will come here. Where will it 360 degree? 180 plus 180, 360. Any mistake I have done? This is 180 and here 180. This is no, it's correct only. 2 pi. What will be this value? It is coming here. So here it will come this one, this one, this one, this one, this one. RY. So VYR. YR it will be this one. What is remaining? This will be RB. Here it will be RB. Is it correct? Can you reply? Hello? Is it clear to all?
Yes, sir.
So now next step, what we can do, this A phase we can consider, and this is the reference they are taking at YB. Okay. So after 60 degree, where it will come 60 degree? 60 degree will come here. Okay. So it will start from this point. This one, again, this one, again, this one. Okay. Now we can match with that waveform. Okay. So what is the second? First one is this. What is the first one? First one they are not asking. What is the second one? Second one is RB. Next one is VRB.
First one is YB, sir. That one.
No, no. See here we are getting first one here. Next one we are getting here. This first is here. So first they have left. Second they are taking X1. So X1 is this one. YB will come on this waveform. Is it clear? See, this first waveform is YP. This first sign is there, no? That will start from this point. That
Yes,
sine
sir.
waveform is YB. Before 60 degree, that is RB. So this line is on before 60 degree waveform. YB is starting from this point, third one. So third one they are not asking. Again they are asking fourth one. So what is fourth one? X2. X2 is VYR. Is it clear?
Okay, sir. Please, sir.
And again they are asking sixth. Sixth they are asking 1, 2, 3, 4, 5, 6. So what is sixth one? Sixth one is okay. 1, 2, 3, 4. We don't have VRY waveform. Any mistake is there? Oh, RY is this only. First will come RY. Okay. So it's correct. Last one is BY. So last one is X3 is VBY. Is it clear? Clear to all? Hello? Am I audible?
Yes,
Sir,
sir.
sir,
You are
clear,
audible,
sir.
sir.
Okay. So in this way we can proceed. First we draw the phasor. What will be the first one? Accordingly 120, 240 will draw. After that we can draw the waveform and match with this one. Okay. Sometimes they will ask which pair will conduct. Okay. So which pair will conduct means which switches will conduct where. Like here they can ask which pair of switches will conduct. So we'll start from the this one. YB is the like reference like this one YB. So here it will be 6 1. You can verify this one also with circuit 1 2 2 3 3 4.
Sir, YB 3-2 now, sir. That one.
Okay. YB. So yes, it is not a generalized, correct only. Here everything is different they have given RYB. But how you are telling? Okay, here reference only itself they have taken different. If this reference is not taken different, okay, if this kind of thing they will not tell, then we can follow that sequence. Okay, 6112. But here we have to see what is YB. For YB, what we need?
3-2,
Y
sir. That one.
hmm? 3 2
P2 N3.
3 2. This is YB
P2 N3, sir. P2 N3. That one, 3 and 2.
3 and 2. So this will YB. YB is this one. It will come 3 2. Okay, what is YR? YR if you see 1
3-4, sir.
hmm,
3-4.
1 second. RY na 3 2. I think 1 second. This is R. See, if everything they will change, then we have to observe. Okay. If some standard thing they will give, like last everything I have explained. Okay. In that case, ABCD will be there. This sequence will work there. Okay. Here actually they have changed the sequence. That's why it's a problem. If they will not change the sequence, then we can analyze by this way. Otherwise, for different sequence also, we can find some short trick. Okay. So see, previously all the sequence what I have taught, there that same thing will work. You can verify with the circuit. Like here, normal phase sequence is normal ABC. So this time I'm starting with AB. I'm starting here. This is waveform 6-1. So 6-1, 1, 2, 2, 3. Again it will repeat. So you can see with the circuit also. It will be same. Okay. But here we can see once. So what we here since the YB, where is YB? Y is this one and B is this one. So in case 3 and 2 is conducting. Again, Y after YB, what is the value? YR. YR. So Y will go here and R. So 3, 4. 3, 4 is conducting Y and
3, 4, and sir.
3, 4. Here it will be totally different. I think sequence will be different because this phase is different. So accordingly we have to make the, so no need to memorize this one for if this phase will be different. If phase will be different, you have to go by basic by observing the circuit. If normal phase sequence will be there, in that case we can memorize this sequence. Like normally if they will ask question, they will not change anything. So in that case we will follow that sequence. Is it clear? I think it is clear.
Clear, sir.
Okay, okay. So some more questions are there. Should I discuss or we can discuss in next class?
We can discuss, sir, now.
Okay, so see. This is last question only I have taken. So GATE 2000, I think 14. Okay. So just by observing this, we can solve this one. Like this. See, this delta connected transformer is connected to the rectifier. Okay. And here what we are getting? Output current constant. So either two of this line will be connected at a time. Okay. Let's say this is 1, 2, and 3. So either this any two will be connected, one will be isolated. So let's see this 1 and 2 is connecting. Okay. 1 and 2 is connecting. So what will be the current? Current will flow through this 1 and it will come by this 2 and this 3 will be open. Okay. And if you see this transformer, every winding have some same impedance Z, Z and Z. Okay. So if this thing will happen, what will be the current in this? Let's say this is A phase. This I am considering as A phase, first one. So if you apply the current division, what will be the current through this one? 2Z divided by 3Z into I naught. Is it clear? Is it clear? Hello. See, this transformer will be there. The winding is there. Let's say A is connected and B is C is open. At a time only two will be connected. Okay. So current will flow here and come here. So this Z, Z and Z. If I want to calculate the current in this one, what will be the value? 2Z divided by 3Z
3Z.
into I naught. So for some case it will be 2 by 3 I naught. Okay. Similarly, if this will not conduct and this will conduct. Okay. What will be the current? Through this one. So one part is this one. So we can say that Z by 3Z into I naught. This all of you can verify for different what will happen. Some part of this will conduct accordingly that 6112 what I have written there. So this just a observation. Like sometime it will be 1 by 3 I naught and sometime it will be 2 by 3 I naught. Is it clear? So if you see the waveform here, that option is not there. Like 1 by 3 I naught and 2 by 3 I naught is only 2 by 3 is there. Here also that same thing is there. Out of these two options, one will be correct. Okay. And what is the transformer equation? N1 I1 is equal to N2 I2. Okay. So here what is given? N1 I1. So 1 is equal to I1 is equal to K I2. Okay. But here if you see it is divided by K is written. But here 2K by 3 and K by 3. So this will be the correct option. Is it clear?
Sir, yes, sir.
So this
Okay.
thing you can do as a homework. Okay. You can what you can do for 30 degree. And next, if it will be not clear, I will explain more depth in next class. This question. Okay. So what you can do for 30 degree? It is given 30 degree. So for 30 degree, you can draw first output voltage. Okay. After output voltage, you can write 6, 1, 1, 2, this sequence you can write. Okay. Accordingly, in some sequence, some 2 points will be connected. Accordingly, you can write the stepped kind of waveform, something will come. Okay. Just by applying the current division here. Is it clear? Hello?
Same as in inverter operation, sir. Inverter
Yes.
will be the
Yes.
analysis
So
like
for
that.
actual, I have told here in shortcut, like just it is we are getting 1 by 3 or 2 by 3. But how to analyze that one? So you should first draw the output voltage waveform, then mark the switches which are conducting. Okay. After marking the switches, at some particular interval, you can apply the current division. Okay. Like what should be the current in this? Let's say this I am considering as phase A. So for phase A, IA, you can draw the current. That same only inverter kind of operation it will be. Correct. 180-degree inverter, I think we are getting this kind of waveform. So,
Yes, sir.
so this one all of you can try. Okay. Like you first draw the waveform V0. After that, mark the switches which are conducting. After that, for all conducting switches, you can visualize this delta diagram and you can apply the current division. And for 60 degree, 60 degree, 60 degree, you can draw the waveform. Then this kind of waveform will come. Okay, just for verifying, you can do that. Otherwise, for answer, we can directly tick since we are getting 1 by 3 or 2 by 3. But in these two options, we are not getting, so this 2 will be eliminated. And here we are getting wrong, like transformer ratio should be, it should be multiplied by K. So this is the correct option. Okay, so I think this was the last question for today. Next class, I will come up with the semi-converter, three-phase semi-converter. So that will be more interesting. I will waveform step by step. I will explain. I think that one is complicated. But most of the coaching, you cannot see the correct explanation for that one waveform. So three-phase semi-converter.
Sir, for three-phase semiconductor, we have to take diode and thyristor turn off times
Both.
different. The same, sir.
Everything I will explain for this one. Whatever I explained here, same analysis we will do there. Okay, we'll see what we are getting. For
Okay, okay,
alpha
sir.
less than equal to some, for some less than value of alpha, it will work same as normal converter, full converter. Okay. When freewheeling action will come after some alpha, if it will go negative, then only some, I will do the waveform analysis perfectly. Okay. So we'll do the waveform analysis, Fourier analysis, okay, and then circuit turn-off time. So this will be the target of the next class. And one more thing I want to cover. So maybe I will not cover, that will be more important part, like source inductance, LS. Okay. So for this one, I will write all the formula in one page, like what formula we have to use. Some one or two derivation I will explain. Okay. Or otherwise, I have the notes, so that I will share in the group. Like because time is less and the exam is nearby. Okay. So that notes directly I will share, and steps I will tell how to solve these questions. And some extra thing which I have analyzed, like that is not asked in the gate, like for this full bridge rectifier, that overall conduction angle will be 120 plus mu. Like one question they have asked in gate 2017. Okay. 2017, one freewheeling diode based question, this source inductance based question they have asked. So they have asked what will be the total conduction time of the diode. So that was 180 degree plus mu. Okay, that was the answer for that question. So first we will start from single phase. Then this kind of concept I will discuss for three phase kind of converter also. So in three phase, this I got the relation that is 120 degree plus mu. Okay. So in one cycle, that one thyristor will conduct for normally how much we are conducting 120 degree. Okay, but finally it will conduct 120 degree plus mu. So this all parts I will discuss, and all previous year question related to source inductance and three phase semi converter I will discuss. So after that, I think it will be completed rectifier part. Okay. So I'll meet on the next Monday. See, if anyone have doubt, like you can post question in group also. Like some any tough question you can try to solve related to three phase, any rectifier based question, and you can post in the group if you are unable to solve. That also I will take in the next class. Okay.
Okay,
Okay.
sir. Okay, sir.
Okay. Okay. So thank you all, and
Sir,
happy New Year to all. We'll meet in the next class.
Thank
Hello.
you, sir. Same to you, sir.
Happy New Year, sir. Thank you,
Sir,
sir.
happy New Year, sir.
Okay, thank you all.
Hello.
Yes.
Sir, you have book for this power electronic in soft copy?
See, various books are there. Like, okay, some books are there. Which book you want? Like, so many books are there. Like P.S. Limbra or various books are there.
Mm,
But no need to go depth in book. Like, whatever I taught, like, that is enough, I think. Question bank I have there. Some question banks I will share. Okay, one good question bank is there.
yes, sir.
That I will share. In that, many questions are there. And book, if we'll see for gate perspective, that one or two books are there. That I will share in the group. Okay,
Oh,
some
yes,
reference
sir.
book I will
Sure.
share. Okay, okay. Thank you all.
Thank you, sir.
Okay, thank you.
Thank you, sir.